Hello seniors, today we're going to continue with electronic assignment number 14, which is about the derivative in graphing. Remember we were starting to interpret how to visualize, to graphically visualize the usefulness of derivatives, right? And in the first example, in the first set of examples, we did 3 exercises, these 3 over here. We use the concept of derivative in order to determine whether the function was decreasing, increasing, or neither, right? And in order to do that, the rule was simple. We found the first derivative of the function and we evaluated the first derivative for some specific values. Remember, we made our number line here and we established different, we first found the critical numbers by setting the first derivative to 0, and then we picked another set of numbers in order to evaluate the sign of the first derivative between those critical numbers, right? And the sign of the first derivative tells us whether the function is increasing or decreasing. If the first derivative is positive, the function is increasing for that interval. And if the first derivative is negative, then the function is decreasing on that interval, okay? So that's what we did last class. Today we're gonna extend this a little bit more and we're gonna talk about relative minimum and maximum points. So let's see what this is about. It says, a function has a relative maximum point, also known as local maximum, when the function changes from increasing to decreasing, right? Whenever we're increasing and then we go decreasing, then we have a maximum point, right? And a function has a relative minimum point or local minimum when the function changes from decreasing to increasing, right? We come decreasing, and then we go increasing. So this point over here corresponds to a minimum point. So it says relative minimum and maximum points are called relative extrema of a function, okay? So these are all names that you should remember because you could see them in IB exams and you should know what they are referring to, right? Local minimum is a maximum point. Local minimum is a minimum point. Extrema refers to either maximum or minimum points, okay? So extrema are just points where the derivative is equal to 0, right? The first derivative is equal to 0. Okay, so then it says, note that if the first derivative does not change sign at a critical number, then the point is neither a relative minimum nor a relative maximum. We're going to see that in a second, which is basically this exercise, the last one we did yesterday. If you remember, the critical number was 0, but before that critical number, the sign of the first derivative was positive, and the sign after that critical number of the first derivative was still positive. And if you visualize this graphically, you will see that this point over here is neither a maximum nor a minimum, and that is called an inflection point, which we're going to see in a second. So here you have what is just stated there. For example, this point over here is a relative maximum, right? This point over here is a relative minimum. And this point over here is neither a relative minimum nor a relative maximum. This is known as, and let me write it here, inflection point. Inflection point. Okay? And okay, you see that in all of the 3 cases, the slope of the tangent has slope 0, right? That's why we set the first derivative to 0 whenever we're finding these critical numbers. Okay, so it says, the first derivative test is used to locate relative extrema of f. If f is defined at a critical number c, then if f prime changes from positive to negative at x equals c, then f has a relative maximum point at c, f of c. Then, if f prime changes from negative to positive at x equals c, then f has a relative minimum point at c, f of c, okay? This is pretty logical, people. You just need to try to think about what's happening in order to see if it's a maximum, a minimum, or neither, okay? So let's see how to apply to the same set of 3 exercises we did last class. We're going to do the same process, but now we're going to determine the relative extrema of these functions. Okay, so I copied and pasted the process we already did last class in order to save some time. But now that we have the critical numbers, we need to see if each of these critical numbers correspond to either to a relative maximum, to a relative minimum, or neither, okay? So how do we do that? Well, if you do the analysis of the signs that we did yesterday, you would easily be able to identify that, for example, this first critical number, -1, corresponds to a maximum, right? Why? Because the function is increasing before that value, and after that value, it starts to decrease according to this sign, right? So this point over here corresponds to a maximum. And the opposite occurs for this critical number too, because the function is decreasing, and then when it gets to that value, the derivative is 0, and then it becomes increasing, right? So this point corresponds to a relative minimum, okay? So it's easy to determine whether it's a maximum or a minimum. But how do we find the value of y of the function for this critical number? Remember, we only found the values of x. Well, it's quite easy. We just need to plug in the values, or the critical number. Let me do first with -1. The critical numbers into the original function, into this one, in order to find the y coordinate of the maximum or minimum point, right? So if we plug in, we're going to get 2 times -1 cubed minus 3 times -1 squared minus 12 times -1. This value would give us 7, positive 7. Okay, so now we know that the point -1 comma 7 corresponds to a, we said, maximum, right? So it's a relative maximum as f prime of x changes from positive to negative. Okay, that's the important thing you should realize. So this is the answer for the first part. 1, 7 is a relative maximum. And the other point corresponds to x equals 2. So we're going to do the same thing. We're going to replace this into the function, and we're going to find f of 2. 2 times 2 cubed minus 3 times 2 squared minus 12. If we solve this, we should get as an answer f of 2 equals -20. -20. So the point is 2, the point is 2 comma -20. And this, of course, corresponds to a relative minimum, right? Because we go from negative to positive. Relative minimum as f prime of x changes from being negative to positive. And if you take a look at the values, you would see that the y value, if you compare the y value of this point versus the y value of this point, you can clearly identify that 7 is greater than -20, right? So it is evident that this point should be above this point. So that's another sign that tells us that this point is a maximum while this point is a minimum. Okay, so that's a visual comparison you can always do to check your result as well. Super. So let's go to exercise B to see what's happening here. This, if you remember, the function was this one over here. Let me see if I can rewrite that function here. I'm gonna leave some space. Maybe there. There. So the function for part B, I'm gonna write it in black. F of x is equal to x squared minus 4 divided by x squared minus 1. This is the original function. So we found the derivative. This is what we did last class. We found this first critical number and these two critical numbers that, if you remember, are the ones that are found by setting the denominator to 0, which causes an indetermination in the function. Okay, so if we analyze the signs of this, you would see something a little bit different. One thing we can say is that x equals 0, this critical number corresponds to a minimum, right? Because we're going from negative to positive. So we're going negative first and then positive. So the point x equals 0 corresponds to a relative minimum. But what is happening with the other 2 points? The problem with the other 2 critical numbers, which are negative 1 and n1, is that the signs are remaining the same, right? Negative and then negative. And here positive and then positive. So we cannot conclude that they are maximum or minimum. So that will be the answer. They are neither, right? They are neither maximum nor minimum points. And later on, we're going to graph this function and we're going to see what they actually are, okay? So, if I find, I already know that for 0 we have a relative minimum, so I'm going to find the y-coordinate of for x equals 0. So I'm going to plug in x equals 0 into the original function, and we're going to say that this is 0 squared minus 4 over 0 squared minus 1. And this gives us, as a result, a positive 4. This is positive 4. So the point 0, 4 corresponds to a relative minimum point. Relative minimum point. Okay, so this is one answer. And for the other 2 values, for 1 and negative 1, if we try replacing that into, let me see, I have space here. If I try replacing these values into the function, let's calculate, for example, f of 1, we're going to have 1 squared minus 4 divided by 1 squared minus 1. And this is negative 3 over 0. Any number divided by 0 is undefined. It's actually infinity. If you remember, I showed you this last year. If I divide by a very small value, I'm going to get a very large number, right? So in the infinity, when I divide by 0, any number divided by 0 is actually infinity. But since there's a negative sign here, the answer would be negative infinity, okay? So negative 3 divided by 0 is negative infinity. Now, if I do the same thing for f of negative 1, for the other critical number, we're going to get the same result, right? Negative 1 squared minus 4 over negative 1 squared minus 1. This is still negative 3 divided by 0. So this is, again, negative infinity. So these 2 points, I'm going to write it as points, but they are actually not points because infinity is not a number. But we could say that 1 comma negative infinity and negative 1 comma negative infinity are neither, let me write it like this, neither maximum nor minimum points. Okay, they do not fulfill the rule in order to be maximum or minimum points. Okay, so that's what we can tell about the function b, right? Later on, we're going to analyze how they look graphically for you to finish understanding all of these concepts. For now, let's go to part C. Exercise C, if you remember, the function is f of x equals x cubed. Let me change this to black, it's better. Black, there. So f of x equals x cubed. We found the derivative, we set it to 0, and we found only one critical number, which is x equals 0. But when we analyze the sign of the first derivative between before and after the critical number, we saw that the sign of the first derivative is positive for both cases. So again, this is a case of neither maximum nor minimum because there is no change in signs. And as there is no change in sign, then we cannot conclude whether it's a maximum or a minimum. Okay? So we're going to find the y-coordinate of this function by plugging in f of 0 into the original function. This is 0 cubed. So f of 0 is, again, 0. So the point 0, 0 is, as we said, neither maximum nor minimum. And in this case, as I showed you in the graph before, if you remember from last class, I showed you the graph for this function, which is this one over here. This is actually an inflection point, okay? Because the function is increasing before that critical number, and then it keeps on increasing for after that critical number, and that's what we call an inflection point. So I'm going to write this is an inflection point. In exercise B, we cannot in exercise B, we cannot conclude that these 2 points are inflection points. Why? Because as I told you, negative infinity or positive infinity are not numbers. So these are actually not points, okay? I just put this like this for you to understand what's happening, but these are not points. So for that reason, I cannot conclude that they are inflection points, as I can do for this, right? Because this is a point 0, 0. We can plot that in the coordinate plane, so we can conclude that in this case we're talking about an inflection point. Okay, so that's it for today's class. In next class we're going to see the second derivative criteria, which you will see is also pretty interesting, and I hope this was clear. If not, please let me know and we'll clear doubts in future live sessions. See you.